This video is going to go into the last piece of our 7EE1 goals. And that goal says I can simplify algebraic expressions by combining like terms. Before we get into how to do that, we need some of the vocabulary that goes along with this section. So within combining like terms, we need to know what this word coefficient means. Coefficient is the number that comes before a variable. The number that comes before a variable, or the number that a variable is multiplied by. So an example of that would be example 3x. The 3 is the numerical coefficient of x. Constant terms. A constant term is a value that is just numerical, meaning a number with no variable attached to it. Okay, so let's put that where it goes, resize it a bit. A value that is just numerical, a number with no variable attached. So an example of that would be, in the expression 2x plus 2, 2 is a constant term. It's a number with no variable attached. And then finally, like terms. Terms are considered like terms when they, so we're going to say terms that have the same variable raised to the same power. I'll move that so you can read it in just a second. The same variable raised to the same power or no variable at all. So constant terms, as we just defined them, are considered like terms. Same variable raised to the same power. So an example we would give of that could be 2x and 3x. If we look at that, 2x and 3x have the same variable, x, raised to the same power. They're not raised to any power, so that would be to the first power. Get some examples of what are like terms and what are not like terms. 2x and 4x are like terms, just like we said in that last example. 2x and the constant 4 are not like terms. 4 does not have any variable. You cannot combine a 2x and a 4. Another example of like terms could be 3y squared and 7y squared. They have the same variable, y, raised to the same power, to the second power. An example of not like terms would be 3y squared and just 7y. So don't be fooled, just because they have the same variable y, this is y to the second and this is y to the first. So those are not considered like terms. We could also do something a little bit more complicated, like 2x to the 4th y and 8x to the 4th y. So in order to verify that they are like terms, we have to look and say, do they have the exact same variables raised to the exact same power? We have an x to the 4th here, and an x to the 4th here, and a y to the 1, and a y to the 1. So we would say, yes, those are like terms. What about 2xy to the 4th and 8x to the 4th y? When we look at these two, don't get tempted to say, oh, that one's got a 4th and that one's got a 4th and it has an x and a y. We have x to the 1 and x to the 4th, y to the 4th and y to the 1. So we would say those are not like terms. Let's go through this list and identify all the terms that are like 2y squared. So if we go through, we've got 18y squared. Y and a y raised to the second power and to the second power. They're the same variable, same power, they are the same. 7x and 2y squared do not have the same variable. 2x squared and 2y squared have the same coefficient. They have the same power, but they do not have the same variable. So we would say, no, those are not like terms. Negative 4y squared. We have y to the second power, y to the second power. That's what we're looking for. So we would say that is a like term. And then 9 is a constant term, and so it's not like anything with a variable. It can only be like another constant. Okay, so 2 out of those 5 were like 2y squared. In this one, identify all terms that are like 14x squared y. So it has to have an x to the second power and a y to the first power. It can have an x or a y to a different power. That would not be like. So negative 5xy, it has x and y, but not x squared. 7xy squared, it has an x and a y, and it has the second power, but the second power is on the wrong variable, so that one's not right. 9x squared y, we have x to the second y, which is the same variable combination as up above. Negative 8 is a constant. It cannot be like something that has variables in it. And 10x squared y, again, is x to the second power y. It's that same combination of variables raised to the same power. So again, 2 out of the 5 of that list were like terms. Okay, so now what do we do with like terms? If they have the same variable raised to the same power, that means that we can add them together. So we've talked about this before, that you can't, if you were just looking at 3g plus 7, you cannot combine those in any way. Those are adding two completely different things. But we can add 3g and 8g. So when we were given a number sentence like this, our first step is to identify the like terms. 3g plus 8g would be 11g. Another set of like terms that we have are this 7 and this minus 2. Now if you look down below at this note, the operation before a given term goes with that number, so that this minus 2, the minus sign or the negative goes with this 2. And remember, we should know that because you can always change minus 2 to plus negative 2, and it means the same thing. So when we combine 7 and negative 2, we get plus 5. 7 minus 2 is 5. So this is the simplified version of this. We took like terms and combined them. G's and G's go together, constants and constants go together, and that's our simplified version. There's nothing else we could do to simplify it. Oh, there's the bell. Last example, and then you will be on your way. And when we look at this next example, let's pick out the like terms. I've got a negative 8v and 2v. Same variable, v and v raised to the same power, 1 and 1. 8v, negative 8v rather, plus 2v is going to be negative 6v. And then finally we have negative 9 plus 10. Negative 9 plus 10 is going to be positive 1. So this sentence simplified, you're going to get negative 6v plus 1. Go on to the worksheet that's next, and then come back for a video that has some more challenging and complicated examples.